Right. We saw version 1 and version 2 RIP, and I was telling you the difference between version 1 and version 2.
Right.
Routing Information Protocol version 1 is a classful protocol. Classful. That is a
Right.
very important point. Whereas RIP version 2 is classless.
Okay.
What does this really mean to us? What does that classless and classful mean?
Are you asking me?
Yeah, try.
All right. A class full, meaning that say for instance, a class C address, which started at 192, it would have to, for a class full, it cannot take a subnet of it. It cannot take a subnet of that 192. It only can take the full class C, full class B, or the full class A. However, classless, it can have a class B network, but it has a class C address. So that's my understanding. It can have a different subnet mask. It can have a subnet mask that has been subnetted. Right, just like that. Right.
Okay. So I also want to add something to this. What you said is correct. I want to add something more to this. You see, if I have a router, let's say R1, and connected to R2, and I got a LAN network, let's say the subnet here is 10.1.1.0/24, and here I got 10.2.2.0/24, and let's say in the middle I got 172.16.1.1, 172.16.2.2 slash, let's say, 16. Now, what do we see here? We see 10 network in two different places. In the middle, you got 172 network. We call this type of network design as discontiguous. Discontiguous network means this is what discontiguous network. You got 10 networks scattered here and there. It's not contiguous, it is discontiguous. It is not continuous. It is discontinuous. You can also say like the discontinuous. You got something else in the middle, like 172.16 in between two 10 networks. So whenever you got discontiguous network, you need a classless protocol. Why? The classful protocols will not advertise subnet mask. They don't do like this. They will simply advertise 10. They don't advertise this portion. Which portion? They don't advertise this. They don't advertise this. They don't advertise this. Whether it is classful or classless network that you are using here, actually we have subnetted. This is classless. At least this one it should advertise. No, it will not advertise. Not even this one it will advertise. There is no field in the advertisement. There is no field to carry the subnet mask.
Okay.
So when there is no field, how will it intimate? How it will inform the other router the subnet mask. Not possible. So when you type this command, no auto summary, it's of no use.
Oh.
It's of no use because the version 1 protocol, they don't care about the subnet mask. There is no field to carry the subnet mask information. Usually, RIP does auto summarization, no doubt, but in version 1, even if you say don't do summarization, it's of no use because they are not going to advertise the subnet mask. Whereas version 2, let's say this is version 2. Version 2 also summarizes by default, and it it advertises 10.0.0.0/8 by default. You see, this is advertising /8 by default. At least it is advertising
something.
Some prefix length, yes, something. The default.
Right,
the default. Right. Why it is advertising /8? Why not 24? Because by default, RIP is designed to do auto summary. So because it is configured to do auto summary, this is the summarized length. 10, you know 10 is class 8. Sorry, class A. The prefix length is /8.
Right.
So when you say now here, no auto summary, it makes sense. What it will do, it will advertise 10.1.1.0/8. No, you said no auto summary.
No auto, you're right.
Yeah,
no, right,
you are cancelling the auto summarization. So it will send the actual prefix length. It is send the actual prefix length. What is prefix length? The length of the mask is what we call as prefix length. Yeah. So version 1, don't use this command. It's of no use.
Right.
Because they don't advertise the length of the prefix. So we got this one without prefix length. Now let's change the scenario a little bit. You see, you got version 1 here also. Both the side version 1. What will happen? If both side version 1, they don't get converged. You see, router 2 will also advertise 10.0.0.0 because both are version 1.
Right.
Both are version 1. They don't have field to carry the subnet mask. So both are advertising 10. Will they learn? They don't learn each other. Router 1 says, I already got 10 network. So whatever comes from router 2, it won't accept. Likewise, router 2 will say, I already got 10 network. So router 2 also won't take what router 1 send. They don't learn each other. So the solution is you need to migrate to version 2. See, I want to tell you something. The other vendors, by default, will have version 2. So there won't be.
Oh, the other vendors.
Yeah, I've seen. Like Huawei, this one, Juniper.
Junipers.
They all have by default version 2. So you don't have this problem there.
Right. But earlier on you said version 1 is compatible with version 2.
But that is not good to mix like that. Of course I do. I did. I said version 1 is compatible with version 2 because say for example if this is version 2, this is going to advertise version 2 updates using multicast status 224.0.0.9. And this guy will say as a version 1, this guy will advertise to an address 255, which is a broadcast address.
Right.
Now, if someone is supporting broadcast, which means what? They are ready to accept any address. That's the meaning. Any broadcast, any.
Right.
So if an update comes from a multicast, it will accept because it is any. It is open to any. But router 2 says I'll only open the packet which is delivered to 224.0.0.9. Version 2 has joined this multicast group to 224.0.0.9. So version 2 will only be responding to those packets that are delivered to 224.0.0.9. And version 2 cannot process version 1's packet because it is not coming with a precise address. It says all, any, 255 means any. So router 2 says, I am sorry, I cannot talk to any. I can only talk to this particular multicast, 224.0.0.9. Yeah. So that is not, though version 1 routers are backward compatible and forward compatible, it's of no use.
Right.
Because whatever router 2 says, it is going to come to router 1, and router 1 will take in a class full way, not classless way. So even if router 2 advertises /24, it's of no use. Router 1 will not understand that 24. It will simply take this part and it will think that I already have 10. I already have 10 because RIP don't focus on this 2.224. Version 1 will not focus on 10.2, that subnetted 2.2. It won't focus. Now, I'm going to take you to the command line and do this lab. After that, we will also do something called offset list, which is a very important thing in RIP, offset list. And then authentication. And then a few more tuning things. Let's go. Enable config interface loopback. Yell is a problem for me. Okay. L00 IP address. And this is going to be 10.1.1.1. And then interface G3/0 172.16.1 and okay, I'm going to paste this here. Likewise, let me go and do it on router 2. And G3/1 will be 2 here. If I make any mistake, please correct me then and there.
Okay.
So I got another interface 4, and this is going to be 2.2. I hope there is nothing more to configure here. The RIP configuration we'll do later. I'm just doing basic.
Right, right.
And I got only one interface here.
Yes, which is that 3. It should be that 3 at the at 03. Right.
Now let us paste this. Okay. Now we are going to configure RIP version 1 first. Router RIP version, no, need to specify. No, need to specify if it is version 1. Network, even if you say 10.3.3.0, it's of no use. It is going to take 10.0.0.0. 172.16. Even if you say 2.0, it's of no use. There is no concept of wildcard mask, nothing. So it is going to take class rounded to the class full. You see, show IP protocol. You can see here, it has not taken the second octet information and third octet information. Likewise here, it has not taken a third. Okay, so whether it is version 2 or version 1, this is how it will. It won't allow you to provide you the mask here. Even in version 2, you cannot specify like this. You cannot specify like this. Even in version 2, you cannot specify like this. It won't accept. It will simply take 10.0.0.0. But when you say no auto summary in version 2, then it will go and copy this exact 10.3.3 from the interface directly. It will copy from the interface. Nice. Now, router 3 is running version 1. But you see here, we learned that version 1 can receive update from version 2.
Right.
That's what we see here. Next is, what we did not learn in the previous class, we did not learn the administrative distance. Every protocol has got a number which will say how much this protocol is preferred. I repeat, every protocol will have a number. That number is called as administrative distance. What does that number explains? It explains how much this protocol is preferred in your router. How much weightage you give for this protocol. How much you prefer. How much do we prefer? For example, the static route. Administrative distance is 1.
Right.
What does that mean? I trust more than RIP. Smaller the number, more you prefer, more you trust.
So let me ask this question now.
Please.
If I configure a static route,
yep,
what will happen to the dynamic route? It will just drop from the routing table?
Very correct. Very correct. You see, if I'll write a static route, same like RIP route, same destination, same prefix length. If it is same prefix length, the administrative distance lower is what preferred. Because static route is 1, RIP route will disappear from the routing table once you put the static route. As soon as we put the static route, the RIP route from the routing table will disappear. I'll show you that in a few minutes. I'll show you. So this administrative distance value, lower is preferred. Let's take another example, OSPF. OSPF also you run, RIP also you run. Both provide same root information, let's say. Both provide same information, 10.1.1.0/24. Which one the router will keep in the routing table? OSPF RIPs.
OSPF.
The reason,
Right.
administrative distance of OSPF is 110. It's 110, 10 lower than this RIP. RIP is 120, OSPF is 110. So lower is preferred. Now, is this changeable? Yes, you can change it. Let me quickly show changing this. Router RIP, you see, distance is the command.
Right.
I can say 100 so that RIP route will be preferred over OSPF.
OSPF. Right.
Show IP protocol. You can see the administrative distance has changed. Now, if I will have both OSPF and RIP providing the same route, RIP's recommendation, RIP's route will be accepted, preferred. Yeah. Okay, next.
Yes.
Let us get into the other details, like you see, show IP protocol. What are the other things that you see here? We see that this can receive version 2, but it sends only version 1, which means it will send only broadcasted updates,
Right.
and they don't care about the prefix length when they send. I would like to show you that, what they send. Do debug IP RIP.
One moment. Wait, say right here said the maximum part 4.
Yeah,
what is it talking about?
We are going there.
What's it talking about?
Okay.
Okay.
Okay, look at this. When it is sending, there is no field called mask.
Right.
Version 1 updates are sent to a broadcast address, and there is no field that carrying mask like /8 or /16. But as soon as I switch to version 2, see what happens. Router RIP version 2. I'm switching to version 2. You will see /8, which is default. Look at this. It started advertising the default.
16, right?
What's that?
And the update to the multicast address.
Yeah, I need a version 2.
Right.
I'm waiting for the 10 advertisement. Let's go. Okay, look at this /8.
Right.
Now, if I say no auto summary, you will see this /8 will be 24 /24.
See, that one become 24. The 172 becomes 24.
Likewise, 10 also will become 24 because on the interface I have given 24. It knows from the interface. It is not copying from what I configured. When I configured, I did not put the mask. You see, it has copied from the interface. Now, let us go and configure the other routers version 2. Debug or UAuth.
Use space. I think it's use space. Yeah.
My L is not typing. That's the problem. Okay, now I understand.
Okay.
Now it is working. So, let us talk about the max path show IP protocol. You see, every protocol will have this information called max path. What does this mean? Not only RIP, every protocol by default will have max path for. What does it mean? You say you got multiple paths to reach some destination, which is here. Now, all the paths, let's say all the paths provide same metric, same hop count. Path 1, path 2, path 3, path 4, path 5. All the paths provide the same metric. Let's say 2 hops. Any 4 of this 5 routes will be there in the routing table. Yes.
Okay.
To reach this 1.1.1.1, you will have path 1, path 2, path 3, path 4. You will have any 4. You have 5 here, right? 1, 2, 3, 4, 5. But any 4 will be there in the routing table. So when you send a packet like 1000 packet, 250 packet go this way, 250 packet, 250 packet, 250 packet go this way. This is what called as equal cost multipathing, ECMP. Equal cost multipathing. How many paths I should use is what this max path means. And by default, auto summarization is on, but I have cancelled it by saying no auto summary.
Right.
No, I think I have put. Did I? Yeah, correct. I said no auto summary. I remember.
Yes, you did. You did.
As a result, it says it is not in effect. But by default,
Right.
if you check up somewhere before changing the summarization, look at this. It was effective earlier. Then not,
Right.
the word not is not here. But now the not is here.
Right.
Okay, now let us go to other routers and configure. Router RIP version 2. Networks are 172.16.0.0. When I put this comment, now RIP will start advertising the routes on both G3/0 and 4/0 because both have got 172.16. Yep.
Right.
Now network 10.0.0.0 and no auto summary. Now I must be learning routes now. Show IP route RIP. Look at this. This is the loopback interface of router 3. I have learned with the prefix length because I've said no auto summary on the other side.
Right.
Now let's go to router 1. Router RIP version 1. No auto summary. Not version 1, version 2. Network 10. Network 172. Now I'm expecting route convergence. Show IP route RIP. Wonderful. So I should be pinging 10.3.3.3. Able to ping. I want to check if the router 3 can ping 10.1.1.1. So I'm going to source from 10.1.1.1, which means router 3 also knows 10.1.1.1. I'm getting a response.
Okay.
Now, on router 3...
But there's something that I saw that I would like to ask a question.
Please ask.
When it says show IP router RIP. And show IP right there. And you see where it says the admin distance, and then one of them, the 10.2.2.2 as 1 and the 10.1 and the 10.3.3.3 as a 2. What is that? The hop count?
Very good. Hop count. That's right.
Oh, okay.
You're right. Okay. That is hop count. If you see here, 10.3.3.3, for router 1, it has to go 1, 2 hop. Only then it will reach 10.
Okay.
Whereas to reach 10 to 2, it's just one hop, just one jump.
Okay.
That's the hop count. 120, that is called administrative distance. Now, you remember on R3, I have changed the administrative distance to 100.
Yes.
It is locally significant. It doesn't need to match with router 1 and 2. So no problem.
Okay.
Show IP route RAIP. Look at this. Here it all says 100. That doesn't matter. No problem. This is not going to be advertised to anyone. This is local. Only if you have more than one protocol. Only when we have more than one protocol, they compare the administrative distance and decide which one to choose. For example, I'm going to write a static route. You see now, I'm going to write a static route for this network, okay? And this will disappear from here. I'm going to say IP route send the traffic to router 2. Now, administrative distance of this is 1. Let's go and verify now. Show IP route. RAIP, there is should not be. You should not be seeing 10.1. You see? 10.1 is no more. It's possibly down.
But I don't see the static route in there either.
Because I said show IP route RAIP.
Oh yeah.
Okay,
yeah.
I have to remove that RAIP one. Okay, now if you see, you will see the static route.
Right. It's something that possibly done.
Yeah, because we just changed it. We just changed the policy, no?
So we have to change. Wait for that.
No, it will disappear now. It will disappear.
Okay, after 240 seconds.
Yeah, 240 seconds. If I say clear IP route start, then you will see that will disappear from the routing table, or you need to wait for 60 seconds, not 240 seconds. 60 seconds. Okay. You see now? Okay. It's gone.
It's gone. Yep.
So administrative distance lower is preferred. Even if you have BGP, which is...
And 1 second. So I realize the static route says 0 hop count.
Yeah, because static route don't deal with the hop counts.
Okay, just straight. Okay.
So that field will always remain 0. They don't learn hop counts.
Okay, that's good.
So let us now try to add some value to that place. 0, you don't want 0, right? If you don't want 0, I can only set administrative distance. I cannot set any metric for that. We cannot do anything.
But I think if I put the distance,
that is for administrative distance. Okay, that is for administrative distance, meaning if you want to change this value. See, I'm going to say 5. Okay. Now you see, show IP route. It is only the administrative distance. 5.
But if you change it to 110, what happens?
RIP route will come. No, not 110, 130. Because 100 okay, we got 100 here.
Yes,
we got 100 here. Yeah, 110. If you change to 110, the RIP route will come in. I'll change it to 110, okay? Yes. Now RIP route will come, static route will disappear. You see? It's going to disappear soon. RIP sends update every 30 seconds, so you need to wait.
Right. Oh, there it is.
Yeah.
Gone.
That is gone. Static route has disappeared because of the administrative distance. Okay, so next thing I want to show here is, very important thing is offset list. Offset list. See, there are various lists we see in networking: prefix list, access list, distribution list. This is offset list. Offset list.
Never heard of it. Never heard of it.
The place where offset list can be used is you want to manipulate the metric. If you want to manipulate the metric of RIP protocol, you need to use offset list. For example, what is the hop count to reach 10.111?
2.
I don't want to see here as 2. I want to see here for some reason as 12. What should I do? You can do it on router 2 or router 1 or router 3. I choose router 2 to do this. But I want to verify in router 3. Okay. I want to verify in router 3. I want to configure in router 2. What I need to do is I need to write an access list 10 permit 10.1.1.0 wildcard mask. You understand this, right?
Yes.
Okay.
Yes.
Now I'm going to say router RIP offset list
10. It should be 10.
and 10. If this 10 matches, set the metric while sending the update out. Okay, while sending the updates out, you need to set what I was telling here. I want to see what 12, right?
12.
Okay.
12.
When you send it out, send 12. Right? Now let us go and verify there in router 2. Clear IP route star. I'm refreshing the routing table. And earlier we saw 2. Now I'm expecting 14 it says.
So it's at 2.
It is that original 2 plus 2. Sorry. If you want 12, then I should have said 10. So 10
right.
plus the original 1 gets added. Yeah. So this is how we use offset lists. So what I did is simple. I wrote an access list to match the prefix to which I want the tuning. And then I said the command offset list, and then I gave the value under the router mode.
Okay. And why would we want to use 12? Why would we want to change the hop count?
Why do we want to change the hop count? Is that your question?
Yeah, yes. Why would we change
Very
the
nice
hop
question.
count?
See, for example, if you are using more than 15 hops, this is 0th hop, okay? And this is the 15th hop. Now, the advertisement 1.1.1.1, which is coming, there are many routers, right? I said 15 hops. Now, the advertisement, when it goes out here, it will go as 1.1.1.1, 16 hop, isn't it? So this router will not accept this update. Why? 16 is poisoned route. 16 is unreachable route. 16 is infinite metric. In such case, I can reduce the offset list here. Like this, you see. Let me go to router 1. Yeah, I'll start from router 1. I'll cancel this one. Router RIP. I cancel this. Now, exit. Go to router 3 and I should see the default one. Okay, it's default right now. Okay.
Yes.
Now I'll go to router 1 and I'll ask router 1 to send with the metric of 15. Access list 10, permit 10.1.1.
I would put 14, and so I would say add 1 to it, so that it be 15.
Wait, let's see. Let's put 15 and see first. Huh? Let's put 15 and see. Wildcard mask. And then router rip. You can play around with this, okay, later. I'm just trying. Anyway, if you get the concept, that is enough for me. Offset list 10 out. I'm going to say 15. Let's see what it shows. And I'm going to say debug and verify what it is advertising. Debug IP rip. I want to see what this is advertising. I can see that it is advertising 10.1. Okay, 10.1 it is ignoring. The reason is
it becomes 16.
Yeah.
See, it comes 16.
16 inaccessible. So let us not put 15. I'll change the offset list to let's say 13.
14.
Huh? 13. Okay. And see now what it said.
It's going to say 14.
Okay. Metric is 14, exactly. Yeah? Metric is 14, it's sending 14. So router 2 will accept this now, no problem for router 2. Clear IP route star. Show IP route. Okay, router 2 says I'm receiving 14.
Right.
Now router 2 will advertise 15 to router 3.
Yes.
And router 3 will also don't have any problem in receiving it, you see. Router 3 also receives it, no problem for router 3.
Right.
Now I'll go to router 2 and say router rip and offset list. Instead of 12, I'm going to say 4. You got it? I'm saying 4.
Yes. Okay.
Currently, what it is advertising? 15. Now I'm saying, no, you say 4. Right? Now,
that's correct.
Check the routing table. Wait some time. A rip route should come.
Okay.
Let's debug in router 2 and see what this is advertising. Debug IP rip.
Sure, it's not 19.
Let's see. Let us see. 10.1.1.1. 10.1.1.1. This is received route. Don't see the received one. We need to see the send one.
Right.
It is sending 16. Sorry.
It's not 16. It's really 19, but But it just shows 16.
16 is the max.
Right. 16 is the max, so it's not going to send 19. So it's like you cannot minus from it.
Yes, that's true. So now what I'm going to say is I'm going to cancel this and I'm going to try to try something else now. Somehow I want to bring the root here. Okay, I want to, if it is 15, it is not going to accept. I want to somehow bring the root here. So you go to router 2 and say the offset list. Okay, when you receive in, I'm saying when you receive the update in, if you find 10.1.1.1, you receive as metric 5.
Yes.
And now let's see what happens.
I think it should work.
Okay, now I go here to route 3, clear the routing table, show the route.
It tells to which one? To 10.1.1?
Yeah, 10.1.1. We are looking into 10.1.1.
But it's a static
We give
route.
some time. We need to see why the routes are not received. Show a debug. Received. Okay. Oh, again this is 16. Again this is 16. So that don't work. So once it reaches 15, it gets added to it. To 15, it was receiving 14. To 14, it was adding number 5.
Right.
Okay, so no problem. This is how it works. If you do not want to show the real hop count, okay? If you don't want to show the real hop count, you want to manipulate it, then you use it, but don't go more than 15. It won't work.
Right.
That's the story.
Right.
If your real hop count is 2, but you do not want to show as 2 hop to router 3, you want to show as 15 hop, then you can use it. Same like what I did.
Okay.
You want to manipulate? You need offset list. You see now? It's 15 now. This is not true. But you achieve this through offset list. So the one who is sitting in router 3, he will think that 10 is 15 hop away. But in reality, it is just 2 hop away. Even router.
And if you do a trace route, it will show you the real.
It will show 2 hops. If you trace route, then it will show you 2 hops. Then what he will think, there is some tunneling concept, something like that. You see, it's just 2 hops and trace.
2 hops, okay.
All right. So routing tables hop count is no way related to trace route hop count. Trace route uses ICMP to know the hops. The routing protocol has got nothing to do. Now, so far what we have seen is the offset list, the configuration, the discontiguous, classful, classless, and some debugs. Now, what I want to do is, I want to enable version 1 on router 3. Yeah? Version 1. I have enabled version 1 on router 3. What will be the result? What are all the consequences we'll see?
Those classless, there is no room for prefix mass length.
Correct. So what will happen? What will be the impact because of me changing to version 1? Okay, I'll ask you a question. Will there be 10.3.3 learned in R1?
No, it's only 10.
Only 10.
But 10 is already there, so
they don't accept it. Very correct.
Right.
Okay, now let us verify. Show IP route. You see, this has got the reachability, this has got the route information, though it is version 1, it can receive update from version 2. Yeah? See, clear IP route star. Show IP route. See, this is timing out actually. 1 minute and 11 seconds. Okay, so I'm showing you the fresh routing table. This is the fresh routing table. Because this already has got 10 connected, it is not learning from version 1 other router because the other router is saying I got 10. Router 3 says I also got 10. Already I got 10.
10.
So they don't learn if you have different versions, you know. Show IP route. You see, they don't learn 10.3.3. Sorry, 10.3.3.
No, I think this timing out.
Yeah, correct.
At 17.
Yeah. Let me go and check it on router 2. You will get the real output. Show IP route. Okay. 10.1.1.1. It is 10.1.1.1. Illegal version. Huh? Updates are coming from illegal version. Yeah, show IP route. RIP.
Gone.
It's still dying. Huh? Still dying.
Yes, and the next one is at next one is at 5.
No, next one that doesn't matter. That is coming from version 2. You see this one. This is dying.
Okay.
This is from router 3. Router 3 is what we made as version 1. Router 3 is version 1. Focus on router 3. Now this is going to be possibly down very soon. You see? Possibly down.
Yes.
Now in another 60 seconds, this will get removed from the routing table.
Okay.
All right. Now, this is the problem. Now, I would like to show you a command on the interface. This is the final touch in RIP. Okay. Interface G3/0. You see, IP RIP. You see, you got a version send receive. What version you want to receive? I want to receive version. You can say what version you want to receive. You can also say what version you want to send. Yeah. So by using this command, you can have one side version 2 neighbor, another side version 1 neighbor. You got it?
So even if you configure, say for instance you configure version 1 under the routing protocol, but you want to send
2
version
on the interface,
2, it will override it.
Yeah.
Okay, overrides. Okay.
Interface configuration will override the global.
Okay.
So if you will have an old router in the adjacent, which supports only version 1, and if you have new router on the right side, which is version 2, you can talk to both.
Right.
In the left, you will use version 1. In the right, you will use version 2.
Right. Okay.
One more thing we have not covered so far in RIP is authentication.
Right.
For this, we need to create a keychain, call the keychain under the interface. Similar configuration we will be doing in EIGRP. So let's not spend time here in RIP authentication. It's same like EIGRP keychain. All right. Only the command difference is this: IP RIP authentication, and you need to call the keychain here.
Right. And what about the keychain?
Yeah.
The word of the name of the keychain.
Correct.
Okay.
No? And then the mode, whether you want MD5 or plain text. It's same like EIGRP. So when we go EIGRP, we'll do that. But you also can try after this class in home. I showed you the command. Keychain configuration is in the global mode. Keychain, and you give a name ABC. Key ID is 1. Key string is, let's say, Cisco 123. And you call this ABC on the interface, which I showed you.
Okay. Yes.
Right. So any question on the protocol RIP.
All right. No question. But the thing is this: once you're in the exam, is when you see the question only come when you're in exam. When you look and you say, what are they talking about? I don't understand.
Okay. After this classes, you should be able to understand. If you can also bring some questions that you don't understand, I can explain you those questions in the class. All right. So definitely now anything related to RIP you should understand, because you have not exposed to, you were not exposed to offset list, you were not exposed to the interface level version configuration earlier.
No.
Now you got all these things. So those are the things that you might have not understood earlier in that question. And now you got these informations, and now you should be able to understand any question in RIP. And if you will find some question, bring it to me. Let me try helping you understanding it. Fine then.
Yes.
What